Good morning, students. So let's start our class. So if you recall, in the last class, we started discussing with a new progression called AGP, Arithmetico-Geometric Progression, and we will discuss little more depth on it. After that, we will discuss another progression that is called Harmonic Progression. Now, I hope you started getting your evaluated paper, dear students, or
Yes,
other descriptive paper you started getting, I hope. Uh,
yes,
or I have evaluated 3 papers and sent you you get automated email also, right? And
yes,
wherever the marks got deducted, you understand the valid reason behind it, right, dear students? All of you
yes.
agree? Yeah. So keep on sending this thing. As I said, that that evaluation will eventually happen. But what is very important is that every day you do this thing. That is why I name this test as DPP, Daily Practice Problem. Okay. So now, can anyone tell me what is arithmetico-geometric progression? I'm asking as I already informed little bit about it in the last class.
Um,
Can anyone say about what is arithmetico-geometric progression? It is fine if you forgot or if it is fine.
Arithmetic progression is when a series has a common
No, I'm not talking
difference.
about arithmetic progression. I am not talking about geometric progression also. I am talking about arithmetico-geometric progression. Okay.
uh,
Is it the one where the terms are the products of the arithmetic and geometry?
Correct, Sagnik, correct you are. I hope all of you are able to view the screen properly, dear students.
yes,
Okay, all right, great. Now, what you see here, arithmetico-geometric progression is something like this. Let us consider the following 2 progressions. If you recall, in that last class I just touched base. The first progression is an arithmetic progression. The first one, okay, it's an arithmetic progression and having first term as A and common difference as D. Whenever arithmetic progression comes to our mind, what we say? First we say, what is the first term and what is the common difference? Correct or not?
yes,
So, the moment you see that is the first one is an arithmetic progression, so what comes to our mind is that something like this. If you see that what I am writing in green color, that is the first term is what? A. Second term should be what?
yes,
A plus D. Third term will be what? A plus 2D. Fourth term will be what? A plus 3D.
yes.
Correct, no, dear students? And so on. The next one, what you see, is in geometric progression, GP. I'm going to write it in the blue color. So, the second one is a GP with first term B and common ratio R. What does it mean? It is B, first term is B, second term is BR, correct or not? Third term is BR square. Let me write little. First term is B, correct?
Yes.
Second term is BR. Third term is BR square. Fourth term is BR cube. Sorry. BR cube. If you recall that, it is A into R to the power n minus 1 is the nth term, right?
Yes.
So in that way it continues. Now what happened, dear students? We are going to construct a new progression in which the first term is the product of the first term of the AP and first term of the GP. That means the first term should be the product of the first term of the AP and GP, that is A and B. What it will be? It will be A into B. Dear students.
Yes.
Second term will be the product of the second terms of the corresponding AP and GP. So what it will be? A plus D into BR. Correct or not? Third term will be what? Product of the AP, third term of the AP, and product of the third term of the corresponding GP. So that becomes A plus 2D into B into R square. Then fourth term will be what? The product of the fourth term of the corresponding AP and GP. That is A plus 3D into B into R cube. Got it? Huh? And then, clear or not clear?
Yes.
So this kind of progression is called Arithmetico-Geometric Progression. So now let me read this statement. Now the Arithmetico-Geometric Progression for the two above mentioned progressions, that is first one is the AP with first term as A and common difference D, and second one is a GP with first term is B and common ratio R. Now, the arithmetico-geometric progression for the above two mentioned progression is a progression where each term is a product of corresponding term of the AP and that of the GP. In mathematical notation, we can write the following sequence is the arithmetico-geometric progression for the above two mentioned progressions. You know, dear students, the direct application of this kind of progression is solving, numericals and numerical problems what we get in mathematics only. As I said, it doesn't have, as I said in the last class, that it doesn't have, much application in physics. So far I didn't get. Now, what we're going to learn, is that how to find the sum up to the first in terms of this arithmetico-geometric progression. Okay, that we are going to find by means of few steps. Okay, and that we are going to do in the next 10 minutes or so. So what we are going to do? Let Sn denotes the sum up to the first, or I can do it in the same page itself. It is better to do. Let me do it here. Let Sn denotes the, let me put it here, the notes first, then we will discuss. So first what we are doing, dear students, let Sn denotes the sum of the first in terms of the above arithmetico-geometric progression 1, as we have given that equation as 1. Then we can define Sn as like what? It is clear that we can write Sn is like this: A into B plus A plus D into BR plus A plus 2D into BR square plus A plus n minus 1 into D into BR to the power n minus 1.
Yes.
All of you are absolutely clear, dear students?
Yes.
Okay. Now, what is our task? Our task is to find the value of this Sn, okay, in terms of what? In terms of the known things are what? A, B, R, D, and N, isn't it? A is what? First term of the AP. B is what? First term of the GP. R is what? Common ratio of the GP. D is what? Common difference of the AP. So in terms of these four quantities, that four known, values, okay, correct, huh? We need to express that Sn in terms of that. You can say, sir, it is already expressed, but thumb is not the way of expressing the formula, na? We need to come up with a formula so that which you can apply. Correct, no?
Yes.
And that we are going to learn in the next few minutes. After that, what we are going to do, dear students, always remember, multiply both sides of this equation. We need to do what? Each and every step follow in details. Okay. And once the class is done, you can do by your own as well. Okay. After that, what we are doing, dear students, is that, first step is, as you already seen, that Sn equal to a into b plus a into b into a plus d into br, a plus d into br square, up to a plus n minus 1 into d into b r to the power n minus 1, which you see in the, the first one. In the second step, what we are doing, dear students, multiply both sides of this above equation, means this equation, by r. What is that r? The common ratio of the geometric progression. Then what we'll get? We'll get r into Sn is equal to a into br plus a plus d into br square plus a plus d into br cube. In that way, last term should be a plus n minus 1 into d into b unto r to the power n. All of you agree, I hope?
Yes.
Correct, no? After that, what is happening is that if there are two cases, if mod of r is less than 1, if you recall, dear students, that we discussed one thing, if you recall, that if we say that mod of x is less than a, always remember, if mod of x is less than a, then what you can conclude, dear students? You can always conclude minus a less than x less than a. Always remember this thing. Why I'm writing this thing? Because mod, when we say mod of x is less than a, what comes to our mind, dear students, is that we do not have a very clear idea what it is actually mentioning, what is the exact kind of values of a. But when we say in terms of inequality, that minus a less than x less than a, it actually gives us a clear idea. Okay, now I have a clear idea what kind of values x can have. Correct, no?
Yes.
Because mod we generally do not use very frequently so far. Henceforth we will use, but so far we have not used. And also another thing, if you find if mod of x is greater than a, then we can conclude two things. Either x is less than a, or sorry, just a minute, either x is less than minus a, or x is greater than a. Mod always returns a positive value. And if you are not able to recall the definition of mod, I can write that thing too as well. I wrote earlier also. Mod of x is equal to, x, if x is greater than 0, is equal to 0, if x is equal to 0, is equal to minus x, if x is less than 0. Correct or not, dear students? Clear? So that is what is called, mod x, and that is why the inequality of mod x. And this concept we are going to apply here. What is that? The first one is that if mod of r is less than 1, that means what? Mod of r of less than 1 means what? That we see that r value of r is in between minus 1 and plus 1. Correct or not, dear students? Correct? If you apply the same formula here, same
Yes.
concept, not formula, same concept. Okay. What I'm saying, something like this. If mod of r is less than 1, that is, if minus 1 less than r less than plus 1, then by subtracting both sides of the equation 3 from the above equation 2, that means we have equation 3 is what? Equation 3, if you see just this one, where both sides are multiplied by r, and equation 2 is just that Sn, what you see, I marked in double tick. Then what will happen? R1 minus R into Sn. So equation 2 minus equation 3. Both sides. So then Sn minus R into Sn, na? That is 1 minus R into Sn.
Yes.
All of you are able to get it, na, dear students? If you do not get, never hesitate to ask me. Then what you are going to get? AB plus dBr plus dBr square. Notice it very carefully. What you get it here from the first two terms, if you see it here, what the first two terms you are getting? AB plus ABR plus BDR, correct or not?
Mm.
Out of that ABR and ABR will get cancelled, na? This ABR.
Yes.
When you subtract this ABR and this ABR would get cancelled.
Mm.
Then what you left with? AB plus DBR. That's what we wrote here. Similarly, for the second term, what we'll get it is that you will get the other things actually getting subtracted. So we'll get something like that, dBr square, dBr power n minus 1 in that way.
Mm.
Are you getting my point, what I'm talking about, all of you?
Yes.
Okay. So then what we are going to get, you are going to get something like this. So if you subtract both sides of the equation 3 from the equation 2, what you are going to get, 1 minus R into Sn is equal to A into B here, left right hand side, plus dBr square up to dBr to the power n minus 1 minus A plus n minus 1 into D into B r to the power n. If you want some time to understand this particular line, you can just open your notebook, write that equation 2, write equation 3, subtract both sides of the equation 3 from equation 2, and you will get this kind of expression, what you see, dear students.
Mm.
After that, things are quite simple. Then what you can do is that if someone wants a time, never hesitate to let me know. Then 1 minus R into Sn become what? AB. I'm just considering this AB as it is. Whatever the AB was there. Now look into this, all this term dBr square up to dBr to the power n minus 1. dBr square, dBr to the power n minus 1. Look into all these terms. We can take dBr common, dear students.
Yes.
So that's what we have done in the next step. We took dBr common.
Mm.
Then what we get? 1 plus R square up to R to the power n minus 2.
That is GP.
That is in GP. Very good. And actually that was the reason that we did all this stuff.
Yeah.
That was the reason we multiplied by R into Sn. If you backtrack, remember, dear students, in one of the DPP, most of you had a doubt in a question called 8 plus 8 into 8 plus 8 into 8 into 8 plus 8 into 8 into 8 into 8. Remember?
Yes, sir.
If you remember, I remember.
Yes.
Yes.
So many batches, but exactly in your batch, what happened, I remember. Remember, a few days back it happened. Na?
Yes, sir.
What we did, we took 8 common, then multiplied both sides. We take 1 by 9 common and then multiplied by 9.
Yes.
Then you get what? 9 plus 9 plus 9 plus 9. Why 9? Because 9 I can express as 10 minus 1.
Yes.
99 I can express as 100 minus 1. 9999 you can express 1000 minus 1. So that 10, 100, 1000 all becomes a GP. Same pattern.
Yeah.
If someone has done the classes with due diligence, can recall what I said in the last few seconds.
Yes.
Then what happened, dear students? That 1 plus R square up to R to the power n minus 2, that entire thing, the formula is 1 into 1 minus R to the power n minus 1 by 1 minus R. Using the formula. Why we are using this formula? Because mod of R is less than 1. Recall, dear students, in my previous class, I discussed that sum up to the first in terms of a GP, there is not a single formula, but there are different branch of formulas depending on the range of values of the common ratio R.
Yes.
When R is greater than 1 or less than minus 1, that is a different formula. That is A into R to the power n minus 1 by R minus A by R to the power n minus A by R minus A. Correct? But when mod of r is less than 1, that is mod of r is in between -1 to +1, means this is the case, dear students. Then what we are getting, it is 1 a into a is 1 na, into 1 minus r to the power n minus 1 by 1 minus r. You can verify this with the formula. Not a big deal. I think I should not spend much time on this. And then what about the last term was there? A plus n minus 1 into d into b r to the power n. Exactly I wrote. Correct, no, dear students? Then what is the formula we get? Sn equal to a into b by 1 minus r plus dbr into 1 into 1 minus r to the power n minus 1 by 1 minus r whole square. Okay, minus, because 1 minus r in the left hand side we actually divided by, correct?
Yeah. Yes.
Left hand side there is 1 minus r, and that we are dividing, and hence we are getting Sn equal to a into b by 1 minus r plus d into b into r into 1 minus r to the power n minus 1 by 1 minus r whole square minus a plus n minus 1 into d into b into r to the power n by 1 minus r. Clear or not clear? You no need to remember this formula. I cannot say very, you can, that is great. But this is little longer to remember, but you should know how we have achieved. You got my point, dear students? You need to know that how we have achieved this particular formula. Correct or not?
Yes.
Now let's do something. If you get an arithmetico-geometric progression in which, mod of r is less than 1 and n is infinite. Think about n is infinite in this particular formula. Means it is one example I gave, dear students, of a infinite geometric progression with where the common ratio is less than 1.
Yes.
That bouncing a ball to take a ball and release, right? Isn't it? Like that, there are several examples. Okay. Then what we generally do is that only one concept, always remember that when r is less than 1, it's a very simple and powerful concept, and lot of people's time you need to use that one as well. When mod of r is less than 1, that means what? Minus 1 less than r less than plus 1, correct or not?
Yes.
When this comes to our mind, we'll see minus 1 less than r less than 1. We'll discuss on all these things in details when we'll discuss a topic called linear inequalities. Okay. Now, whenever you get this kind of situation, dear students, the value of r is in between -1 to +1, then in r power n tending to 0 as n tending to infinite. I explained this thing earlier. Like that, you take r as a fraction. When the value of r in between -1 to +1, that means what? That means r is a fraction.
Yes.
Now, fraction, if you power by a big number, it is tending to 0. Let me give an example. 1 by 3 is a fraction. Na? You know the value of 1 by 3 is less than 1. Now you make 1 by 3 power 1000. That will be very, very less. Correct or not? Even lesser. Make 1 by 3 power 1 crore. It is very, very, very less. That means tending to 0 as n tending to infinite. What is n there? 1 crore I said, no? But you can say, sir, 1 crore is not tending to infinite. To me, 100 crore tending to infinite. Chalo. Then 1 by 3 power 100 crore will be even lesser. So that in a limiting concept means what? That when you are not exactly getting the value, but you are approaching towards that value, what we can say, dear students, is that, when n tending to infinite, r to the power n tending to 0. And exactly we use that formula while working on that infinite geometric. We use this concept while devising the formula for infinite geometric progression, if you recall. Then what happened, dear students, is that I'm just giving a special case of this particular formula we just derived, is that now without loss of any generality. That is a mathematical, statement. Sometimes we say, without loss of any generality means is that, okay, let's assume this thing, okay? There is no, in general, that statement we can assume. That's a mathematical statement called without loss of any generality. We consider mod r is less than 1. That is minus 1 less than r less than 1. So we see that as n tending to infinite, r to the power n minus 1 tending to 0 and r to the power n also tending to 0. Na? Whenever I say 1 by 3 power 100 course is tending to 0, that means 1 by 3 power 100 core minus 1 is also tending to 0. Na?
Yeah.
Limiting concept. I give an analogy. What is that infinite kind of this thing? Okay. When we say r to the power infinite and r to the power n, when n tending to infinite, r to the power n minus 1, value will remain the same. As if like that, from the ocean, Pacific Ocean, if you take one drop of water, do you believe the volume of the Pacific Ocean's water will get reduced? Not really. You take a drop of water from a big ocean, that volume will not, change. You may say mathematically, no, sir, volume will change because there is some specific volume of specific ocean. Na? No, but that value I question. You cannot predictably say this thing. The moment you are computing the volume of that, water, rain happens. Correct. Then you get some more amount. So it is very difficult. It is impossible, not very difficult. It is impossible to find. Now, in that situation, if you take a drop, you really cannot say that, the volume of the specific ocean has reduced. Like that, I just give an analogy. So then what we get is that we see that both these terms, the moment we see that r to the power n minus 1 tending to 0, then this dBr into 1 minus r to the power n minus 1 actually reduces to only 1, correct? No? So that's what we wrote. So by 1 minus r to proper, so dBr by 1 minus r whole square, correct? Now here r to the power n is 0, so that means this term completely reduced. It's not there at all. Correct, dear students?
Yes.
Any doubt at any point of time, never hesitate. Okay? Yukita, everything fine? Disha, Divanshu?
Yes, sir. Understood.
Sure. That means everything clear, right? Now the next point. Yeah. The next point what we are going to discuss is that if mod of r is greater than 1, or the other way we say, there are two cases when r is greater than 1 or r is less than minus 1. Then what is going to happen? When r is greater than, so this is another case, that if r is greater than 1 or r is less than minus 1. And that we are going to study now. If r is greater than 1 or r is less than minus 1, then by subtracting both sides of the equation 2 from the above equation 3, you only get, this formula. It is nothing but exactly what you got in the equation 4. It's negation. That's it. As if you can say that, right hand side you are just subtracting. Why so? When r is mod of r is less than 1, then 1 minus r is positive, na? That's why we did 1 minus r. But when r is greater than 1, then you did r minus 1. Got it, na?
Yes.
So this is the formula you get in this case. Correct, dear students? Which is not exactly negation of this formula of 4. You see? So this is all about Arithmetico-Geometric Progression. Okay. I took time to explain how we find that SN. Okay. I explained this thing because these steps you need to follow whenever you get the relevant questions. Not that you can always remember the formula. You can remember the formula, it is good. But in worst case, if you are not able to remember this formula, here I will not restrict you too much. then you can at least use these steps to follow. Okay, now we will move to the next topic. As I said in the beginning of the class, that we will discuss about the harmonic progression. And that is the last about in this progression. Okay. Later we'll discuss about the series and those things we will discuss, and we'll discuss series. It is something different that we'll discuss later. Okay, but today we will discuss about the harmonic progression. Okay, dear students.
Yes.
Great. So harmonic progression, concept wise, it is very, very simple. Okay. Before writing anything, let me tell you. Then the terms, a sequence called A1, A2, A3, ... will be said in harmonic progression if the reciprocals of these numbers, like 1 by A1, 1 by A2, 1 by A3, are in arithmetic progression. Are you getting my point, dear students? For example, you know that 1, 3, 5, 7, 9, 11, and so on is in arithmetic progression, dear students.
Yes.
Then they are reciprocal, that is 1, 1 by 3, 1 by 5, 1 by 7, 1 by 9, 1 by 11, and so on. They are in harmonic progression. As simple as that, in very simple terms. So I didn't write anything, but I just said you so that it can you can think about it. And now I'm going to show you this one. What is harmonic progression, dear students? A sequence, as you see in the my digital board. A sequence A1, A2, A3 is said to be in harmonic progression. Harmonic progression is denoted by HP. Harmonic progression if the sequence 1 by A1, 1 by A2, 1 by A3, and so on are in arithmetic progression. Correct? And vice versa. Vice versa also. If vice versa means what? If 1 by A1, 1 by A2, 1 by A3, they are in, arithmetic progression. Okay, then A1, A2, A3 should be in harmonic progression. Correct or not?
Yes.
Each and every term of an harmonic progression must be non-zero. Why?
Yeah.
If any term of this harmonic progression is zero, then that reciprocal will be undefined. No? Something by zero is undefined.
Yes.
So that corresponding term in the arithmetic progression will be undefined. Hence, this is a constraint. It is also to be noted that the best way to solve questions from harmonic progression is to first invert the terms which are in AP and then apply the formula of AP. Think about, there is a question. Question is that, think hypothetically that A1, A2, A3, ... up to AN, they are in harmonic progression. Find the sum up to the first n terms. What will you do first? 1 by A1, 1 by A2, 1 by A3, all up to 1 by AN, they are in arithmetic progression. In that arithmetic progression, we can find the sum up to the first n terms. No?
Yes.
Are you getting my point or not? Correct or not? Or the nth term on all these things. So that we will see how we can apply this thing. Got it, no?
Yes.
So here mainly what happens is that, first we'll find, the nth term. Are you getting my point or not? Very clearly? Hello?
Yes.
Okay. So some key formulas related to the harmonic progression. And that if you can remember, that will be very great. Okay. Otherwise you can, devise this formula using the steps what I just mentioned, that convert into arithmetic progression and then proceed. What is that? is that if we know the first two terms A1, A2 of harmonic progression, we can find the nth term, which is denoted by Tn of the harmonic progression by means of the following formula, that Tn equal to A1 A2 by A2 plus n minus 1 into A1 minus A2. I strongly recommend, dear students, to you to remember this formula. If we know the first two terms A1, A2 of a HP, we can find the nth term denoted by Tn of the HP by means of the following formula. Tn is equal to A1 into A2 divided by A2 plus n minus 1 into A1 minus A2. Correct? In case you are not able to remember this formula, what you can do, you can take, as A1, A2 are in HP, so 1 by A1, 1 by A2 should be in AP. Na? From there, you can find their common difference, that is 1 by A2 minus 1 by A1. And then you know the nth term formula of an AP and you can apply that. But I will strongly recommend that you remember this thing. Correct?
Yes.
Now, if you think, dear students, that we discussed about arithmetic mean related to arithmetic progression. We discussed about geometric mean with respect to geometric progression. Similarly, there is harmonic mean when we discuss about the harmonic progression. Correct, dear students? You see it here, something like this. If HM is the harmonic mean, between the numbers A and B, then how we can find the HM? That is equal to 2AB by A plus B. Here again, dear students, you can take that as A and B are the two numbers, we are finding their harmonic mean. We can just say one thing, is that we can take 1 by A and 1 by B, find their arithmetic mean, and reciprocal of the arithmetic mean should be the harmonic mean. Na? Let me show you. So our purpose is to find the harmonic mean between the numbers A and B. Na?
Yes.
So what we are going to do is that, so we take the numbers 1 by A and 1 by B. Fine, na? And find that arithmetic mean between them. Suppose AM. So what will be AM if you recall?
1
AM
by,
will be 1 by A plus 1 by B. Correct or not?
yeah.
1 by A plus 1 by B divided by 2. So for example, if we simplify a little bit, what we'll get? A plus B by 2AB. So we need to find the harmonic mean, we just need to, reciprocal, we need to make the reciprocal of that arithmetic mean, correct or not?
Yeah.
1 by AM, that is equal to what?
2AB by A.
2AB by A plus B, what I wrote in the left hand side. Correct or not?
Yes.
In that way also you can find it out. Now, the few points, generally, harmonic mean, questions generally come rare, but they do come as well. So if you need to choose, let me ask you this question to all of you. All of you, please listen to this question very carefully. If I ask you to choose 3 consecutive terms of a GP, what you will prefer to choose?
The A by R.
Okay. Okay, R may not be the very good thing to say. If you say nothing can, then you need to say R is the common difference. Correct. But R generally is a common ratio. Na? You see, anywhere we discussed about R here in a harmonic progression, no? Na?
Yeah.
So, Sagnik, anything to say? Devansu, if you need to choose 3 consecutive terms of an harmonic progression, what you prefer to choose? Disha, Srijita. So it should be 1 by a minus d, 1 by a, and 1 by a plus d. Correct, no, dear students? 1 by a minus d, 1 by a, and 1 by a plus d. These are the three consecutive terms of a GP. Correct? Now you need to choose the 4 consecutive terms of a GP. What you will prefer to choose? Anyone can answer this thing? Vivansu, Disha, Srijita, Sagnik.
1 by a minus 3d, 1 by a minus 3, 1 by a plus d, and 1 by a plus.
Correct. Very well said. These are the 4 numbers we are going to choose. It is 1 by a minus 3d, comma 1 by a minus d, comma 1 by a plus d, and 1 by a plus 3d. And you know, dear students, we do not proceed after that as long as the choosing the consecutive terms and are concerned, and also not devising any generic formula, because this kind of problem never comes. So hence we should not. There are a lot of things to cover. But next to statement, what I'm going to make is extremely important. Extremely important, dear students. Okay, I'm going to discuss a new page. I explained its importance in the last class also. If you remember, for any 2 numbers, if you take 2 numbers, their arithmetic mean is always greater than equal to geometric mean. Correct or not?
Yes.
And I also proved that. Now, as we learned another progression today, that is harmonic progression. So there is a new things, and that I'm going to explain you now. Okay, let me first, this is extremely important for solving lots of problem in algebra, in theory of equations, in linear inequalities, and you should stick these concepts in your memory like absolute, that you will never forget. Please, very, very important. What is that? Suppose we have 2 numbers a and b. By the way, any 2 numbers are always in arithmetic progression, always in geometric progression, and always in harmonic progression. Correct or not? Unless you introduce any third term. Let M, GM, and HM. M is the subscript here. M, GM, HM be the arithmetic mean, geometric mean, and harmonic mean of 2 given numbers A and B respectively. Okay. Then the first and foremost thing is that, very, very important, is that arithmetic mean is always greater than equal to geometric mean, is always greater than equal to harmonic mean. Got it, dear students? And second thing is that geometric mean square is equal to the product of harmonic mean and arithmetic mean. Very, very important. Extremely important. I repeat, you may wonder that why sir is repeating so many times the same statement, but there is a purpose of it. You will find in future, when you will be solving lots of questions related to theory of equations, linear inequalities, I'll come back to this thing and I'll ask you that why you are not applying this particular concept, why you are not applying. Okay, then you'll realize, yeah, sir told once while discussing in the sequence and says this thing so many times. Okay, and not only it is for 2 numbers, you can consider n numbers, and that is there in the next point. Let AM, GM, and HM be the arithmetic mean, geometric mean, and harmonic mean among n positive numbers a1, a2, a3 up to an respectively. Then we get the following. Arithmetic mean is equal to what? a1 plus a2 plus a3 up to an by n. Correct or not? We just extending that problem. Okay. Now geometric mean should be what? It should be the nth root of the product of a1, a2 up to an. Remember, dear students, when you take 2 numbers, What was the arithmetic mean? A and B. It is A plus B by 2.
Yeah.
Now, when you are extending it to n numbers, we are just adding all those numbers and dividing by the total number of numbers, I mean n. What was the geometric mean? When you took two numbers, it is a positive square root of A into B. Now, when you take three numbers, then what will it be? It will be cube root of ABC. If you take four numbers, it will be fourth root of ABCD. Correct or not? Its extension is that if you take that GM is equal to nth root of A1, A2, up to AN, this one. AM, you find it out, and there is a symbolic representation. You recall in one of our previous class, I discussed about the summation and the product symbolic representation. Correct? And what was the harmonic mean, dear students? Harmonic mean, you can say in one simple term, is that 1 by arithmetic mean. Correct or not, dear students?
Yes.
And 1 by arithmetic mean is what? It is 2 by, I'm sorry, arithmetic mean, yeah. So we can write 2 by A plus B, correct or not? And that we can write in terms of harmonic mean terms is that 2AB by 1 by A plus 1 by B, correct or not? Correct or not?
Yes. Yes.
So the same thing here. This is the harmonic mean, correct or not? So, and in n terms also, arithmetic mean is greater than equal to geometric mean is greater than equal to harmonic mean. Always remember. Clear?
Yes.
Absolutely clear this thing, dear students? All right. So, this is what I wanted to discuss about the, arithmetic mean, harmonic mean, and geometric mean. Now, I'm going to give you some very interesting, tips. And after that, we will conclude the class for today. So very interesting tips, dear students. How just by giving the three consecutive terms, suppose I give you the three consecutive terms, okay? Now, how we can determine whether this is in arithmetic progression or geometric progression or harmonic progression? Okay, dear students? How we can recognize first? You can always recognize by taking 5 minutes or 2 minutes like that around some time. But how just quickly we can recognize that arithmetic progression or geometric progression or harmonic progression. So this I'm going to discuss now. And these are the learning pattern for entrance examinations, so that it will help us to find quickly which AP or whether it is AP or GP or HP. So here it is. Let me first read out. Let three consecutive terms A, B and C, A, B and C. Now the value of the ratio A minus B by B minus C determine whether it is an arithmetic progression or geometric progression or harmonic progression. What is the logic? Here I am going to mention the logic. Just give me a few seconds. Oh, sorry. Just give me a few seconds, dear students. So the logic here is that if that ratio A minus B by B minus C is equal to A by A, then ABC are in AP. If that ratio is equal to A by B, then ABC are in GP. Or if that ratio is equal to A by C, then ABC are in HP. Got it? This is a simple logic. You can always, you can always find it out. Okay. On the other hand, what we can say is that, on the other hand, we can say 3 consecutive terms ABC of a sequence will be in AP if B is equal to A plus B by 2, A plus C by 2, I'm sorry. Okay, so let me write it down. In fact, I touched base this particular point earlier also, and that was that if you recall, that when two numbers are always in arithmetic, you can always say they are in arithmetic progression, geometric progression, or harmonic progression. Now, when there are 3 numbers, suppose, on the other hand, we can say 3 consecutive terms A, B, C of a sequence will be in arithmetic progression if B is equal to A plus C by 2. They will be in geometric progression if B is equal to square root of A into C. And they will be in harmonic progression if B is equal to 2AC by A plus C. Because what are those numbers? They are their mean, na? Arithmetic mean, geometric mean, harmonic mean. 2 numbers always in progression, right? Either arithmetic or geometric or harmonic. But if you insert their mean in between them, then these 3 numbers become the progression. Corresponding progression, arithmetic mean. If you insert arithmetic mean, then these 3 numbers will be in, arithmetic progression. If you insert geometric mean, then they will be in geometric progression, and same thing for harmonic progression. You got my point, dear students, what I'm talking about?
Yes.
Suppose A and B, 2 numbers are always in any progression. But if you insert in between arithmetic mean, they will come in arithmetic progression. If you insert geometric mean, they will become in geometric progression. If you insert harmonic mean, they will be in harmonic progression. Correct or not? These 3 numbers means A, AM, B, A, GM, B, A, HM, B. Clear, not dear students? So in general, what we can say, that is the last point for today. So the generic statement I would like to mention, and then we will conclude the class for today after I give a few assignments. Okay. So in general, a sequence AI for I belongs to N will be in arithmetic progression or in geometric progression or in harmonic progression. It should be or here. There is a small typo at my end. Okay. If the following condition holds true between 2 consecutive terms an minus 1 and an. If an minus 1 is equal to constant for all n greater than equal to 2, then the sequence is in AP. If an by an minus 1 is equal to constant for all n greater than equal to 2, then the sequence is in GP. And if 1 by an minus 1 by an minus 1, n minus 1 is subscript, by the way. That means the previous term than an constant for all n greater than equal to 2, then this sequence are in HP. So dear students, I hope you got all the points clearly. Correct? Correct, no, dear students? Any doubt here, you please let me know. Now, I would like to give you some assignments, and I want you to solve these questions before we start our class tomorrow. Tomorrow, what we'll do, dear students, tomorrow we'll discuss about series. Okay. Tomorrow we'll be discussing about series, and the problem what I'm going to give you now, that you need to solve it and send it to me before we start our class tomorrow, and you will get all the assignments right now along with the DPPs. Okay. Okay, so the questions what I'm giving, dear students, are a little bit of challenging questions that you need to, work on with proper due diligence, and you need to think about it, these questions. But these are very important for JEE Main and JEE Advanced type of questions. Okay. Along with the DPP is what you are solving, so definitely. But at the same time, I can tell you these kind of questions, what I'm giving today, I will be giving in another, few minutes, that will never come to your board examination. It will never come in board examination. This difficult level of questions will never come in board examinations. For board examinations, what is important is that, the DPP, what you are doing, that is very, very sufficient for the board examinations. So the 5 questions I'm going to give, and I want you to, apparently, if you look into it, you'll find that, sir, these are not the questions of arithmetic progression or whatever you are giving, but you'll see that how application of those actually going to help you. Okay. I hope you are able to view this question, dear students.
Yes.
Okay. So I hope you have done till DPP 10, right?
Yes.
Do 2 more DPPs, 11 and 12. Okay, dear students. And after that, you start applying, answering this question. Do not answer these questions right now. Okay, because our preparation has to be step by step. Step by step is the sense is that we need to have good enough confidence by solving the DPPs. Once we gain enough confidence, then we come to work on these problems. And never ever hesitate about if you find any questions is difficult. When you find any question is difficult by solving by the same questions is actually difficult by so many students outside your home. Only thing is that we should not lose hope. What you should do is that, very important statement I am making, dear students. Never worry about that, what will happen, I am not able to solve this problem. No, this thought process is wrong. You should always think what I should learn, what I should do, and how should I, engage with my teacher so that I can qualify to solve these questions. Never worry about that what will happen and this thing. You only think about how I can learn, how I can apply this concept. Okay, what I was missing. Very important, because it is a long haul for the next 2 years. It is going to be a very very detailed preparation. But by looking into these apparently difficult questions, if you think, oh, what will happen, I'm not able to solve this problem, then I'll not able to solve any problem. This kind of thoughts should never come to your mind, dear students. Because if this thought, it can come to your mind, but immediately you should, eradicate by, remembering my statement, what I'm talking to you right now. Yeah, that Sat told not to worry about what will happen, but at the same time, you must be serious about how to learn new things so that I can solve this kind of questions. I am not here to give you lectures, dear students. I am telling you exact the mental situation what a student actually go through. Absolutely, this I have realized. Okay, the moment you worry about a lot of things, we are just killing our precious resource that is called the time. So with this note, I would like to conclude the class for today, unless you have any specific question for me. Okay, so our next class tomorrow at 9 o'clock in the morning. And we will be starting discussing on topic called infinite series. What we will be discussing, just a quick idea about infinite geometric series. Then we'll discuss about exponential series. Then we'll discuss about Euler's formula. Then we'll discuss about logarithmic series. Okay, and then also we will discuss these solutions of these questions, whatever the 5 questions I gave. Correct, not dear students? You will find that these 5 questions may be relatively difficult to solve, but when I will be discussing the solution tomorrow, then you'll find, oh, how I can apply my existing knowledge. When I'll solve this problem tomorrow, dear students, you'll find I'm not using any prior knowledge. Or sorry, I'm absolutely other way. I'm all using the prior knowledge whatever we have learned. I'm not bringing some new concept to solve that problem. Whatever the prior knowledge we have, we need to use those knowledges in a complementary manner. Okay. With this, I would like to conclude the class, dear students. Thank you very much.
And sir, I had some doubts in the previous DPPs, the set 6 to set 10.
Oh, okay, sure. We can discuss right now if you have time. I'm also fine. Or you can take it offline. You can tell me what are the DPPs, which DPP, which. You do one thing. You send me a WhatsApp message immediately after the class. And
Yes.
tell me which DPP and which question number.
Yes.
And then not only that, then you will also tell me, sir, you already submitted the DPPs, no?
Yes.
And then what I'll do, I will first get the question from you. Then I look into your solution, which is already you submitted in the KonarClasses.com, portal, right? So from there, I will take that one and I'll guide you. And that will be done by today before we start our class tomorrow at 9 o'clock in the morning, correct? Is it fair enough?
Yes, sir.
Okay, thank you.